Bismillahirrahmanirrahim. My dear students, welcome to everybody today's class. The topic today's class is about complex numbers. Okay, let's get started. Do you know what is complex number? Let me tell you first. Suppose x and y be two real numbers, then z is equals to x plus iy is called the complex number. Complex number has two parts. One of them is real parts and another of them is imaginary part. Now here x is the real part and iy is the imaginary part, and I is the unit of imaginary number. Now let me tell you first what is I. I is equals to root of -1. Now by squaring you will get I square is equals to -1. Now if you take I cube, then I cube can be written as I square into I. I square is nothing but -1 and I as it is, so you will get -I. Now if you take I to the power 4, then I to the power 4 can be written as I square into I square. I square is -1. Again I square is -1, then you will get 1. Now can you tell me what will be the left with I to the power 5, again I to the power 6, again I to the power 7, and so on. This is your homework. You have to find out. Now I am going to talk about the geometrical representation of a complex number. Robert Argon first introduced the complex numbers graphically. This graphical method is known as Argon's diagram. In that method, x-axis is considered as the real axis and y-axis is considered as the imaginary axis in the xy plane or coordinate plane. And the complex number z is equal to x plus iy is considered as the ordered pair x comma y, in which x comma y belongs to the set of real numbers. Okay. Now suppose the ordered pair x comma y corresponding to the complex number z is equals to x plus iy. And let us say this ordered pair by P. Now let us draw a perpendicular PA from the point P and join the point O and P. And by joining these 2 points you will get the line OP. Now let us say the polar coordinate of this point is r comma theta. So r represents OP and theta is the angle with the positive direction of x-axis, and OA is equals to x and AP is y. So you can write x is equals to r cos theta is the first equation. Again y is equals to r sin theta is the second equation. Okay, because x is the horizontal, so you can write x is equals to r cos theta. Again y is the perpendicular, so you can write y is equals to r sin theta. Now by squaring 1 and 2 you will get 1 square plus 2 square, then you will get r square cos square theta plus sin square theta is equals to x square plus y square. So r square cos square theta plus sin square is nothing but 1. So r square is equals to x square plus y square. And if you find the value of r, then you will get root of x square plus y square, and that will be the modulus of this complex number. So R is the modulus of this complex number z. So modulus of z, that is modulus of x plus iy, can be written as root of x square plus y square. And this is the method to find modulus of any complex number. Now we need to find out the argument of a complex number. For this, you need to divide 2 by 1, then you will get 2 by 1, then you will get tan theta is equals to y divided by x. So theta is equals to tan inverse y divided by x. If the theta lies between minus pi less than or equal pi, then it is called the principal value of argument. So we got the argument of a complex number theta is equals to tan inverse y divided by x. Now if we need to find out the modulus of any complex number, then you can apply the formula r is equals to root of x square plus y square. And if you need to find out the argument of a complex number, then you can apply the formula theta is equals to tan inverse y divided by x. Now I am going to find out the modulus and argument of different types of complex numbers. Suppose x plus iy is a complex number. This is the first complex number. Again, minus x plus iy is the second complex number, and minus x minus iy is the third complex number, and x minus iy is the fourth complex number. Now we are going to find out the modulus and argument of these complex numbers. Okay, now let's start with the first one. Now, what is the modulus of this complex number? R is equals to root of x square plus y square, because here the ordered pair is x comma y. So R is equal to root of x square plus y, and the ordered pair x and y corresponding to this complex number lies on the first quadrant. So theta is equals to tan inverse modulus y divided by x. Okay, now come to the second one. What is the modulus of this complex number? Modulus of this complex number is root of x square plus y square, because the ordered pair is minus x comma y. Minus x comma y ordered pair lies on the second quadrant. Okay, so the argument of this complex number is pi minus tan inverse y divided by x. Now, if you come to the third one, then the modulus of this complex number is root of x square plus y square, and the ordered pair minus x minus y lies on the third quadrant. So the argument of this complex number is minus pi plus tan inverse modulus y divided by x. Now for the last one, modulus is r is equal to root of x square plus y square, because the ordered pair is x comma minus y, and the ordered pair x comma minus y lies on the fourth quadrant. So the argument of this complex number is minus tan inverse modulus y divided by x. And this is how you can find out the modulus and argument of different types of complex numbers. Okay, now let's see what is the polar form of a complex number. Coming back to the complex number, z is equals to x plus iy. Now you can substitute x and y by their values. X is r cos theta and y is r sin theta. So by putting these two values, then you will get cos theta plus I sin theta, and z is equals to r into cos theta plus I sin theta. This is the polar form of a complex number. Okay, now let's see what is the conjugate complex number. Finally, let's talk about conjugate complex number. For this, coming back to the complex number z is equals to x plus iy. Now, if you change the sign of imaginary part, then you will get x minus iy, and you can denote it by z bar. Then ultimately you will get z bar is equals to x minus iy, and that will be the conjugate complex number. Okay, and that's all about complex numbers. Thanks everybody. Allah Hafiz.